Good morning, ma'am. This is Vishnuvardhan from CSCG section. Today topic name is T flip flop. My roll number is 244G1a05eq and basic operation of T flip flop. The T flip flop toggles its output when the T input is high. If the T input is low, the output remains unchanged. This characteristic makes it useful for counting operations. The toggle flip-flop complements the signal of the input T. If the T input is high, the T flip-flop changes state whenever the clock input is changed. If the T input is low, the flip-flop holds the previous value. The behavior is described by the characteristic equation. Truth table. The truth table outlines the relationship between inputs and outputs. When t is equals to 0, the output remains same regardless of the clock pulse. We can see in this diagram. When t is equals to 1, the output toggles with each clock pulse received. We can see in the problem circuit diagram. The T flip-flop can be constructed using a D flip-flop and additional logic gate. It is typically incorporates NAND and NOR gate to achieve its toggling function. The circuit diagram helps visualize how the T flip-flop operates. We can see that NAND, NAND, and NOR, NOT. Timing diagram. In a timing diagram, we can see that a timing diagram illustrates the relationship between the clock signal and output state. It shows how the output changes in response to clock pulse and T input. Understanding the timing diagram is crucial for designing synchronous circuits. Applications. T flip-flop are widely used in digital counters such as binary counters. They also serve as memory elements in sequential circuits. Additionally, they can be found in frequency dividers and shift registers. Advantages of T flip-flops simplify the design of binary counting circuits. They require minimal components compared to other flip-flop types. Their toggling ability makes them efficient for many digital applications. Disadvantages of T flip-flop. T flip-flop can suffer from glitches if not properly synchronized. They may introduce propagation delays affecting circuit performances. Their toggling nature can lead to uncertainty in specific applications if not managed. We can see in Instagram and WhatsApp, Facebook and Twitter and etc. And variants of T flip-flop. Variants includes synchronous and asynchronous T flip-flop. Synchronous T flip-flops changes output only on clock edges, enhancing stability. Asynchronous variants can change output immediately with the T input changes. Conclusion. T flip-flops are essential components in digital electronics. They provide a simple solution for creating binary counters and memory storage, and understanding their operations is crucial for anyone working in digital design. And also we can see the circuit diagrams T flip-flop and JK flip-flop and SR flip-flop and D flip-flop. In this we can see that NAND gate and NOR gate, and JK flip-flop we can see that NAND gate and AND gate, and SR flip-flop we can see that NAND gate and NAND gate. And the flip-flop, we can see that NOR gate, NAND gate, and XOR gate references. Digital design by Morris Mann 5th edition and Camos Digital introduced by circuit analysis and designed by the Sungoma electronics principle and applications by Alberto Manchlo Davids and thank you.